All right. Okay. What's the first thing we're supposed to do? All right. P over Q. So factors of 18, 1, 3, or 1, 2, 3, 6, 9, 18. Factors of 3, 1, and 3. So that creates this list, plus or minus. Let's see, fractions will end up being 1/3, 2/3, and then the rest of them 3 goes into evenly. So that's just the list: 1, 2, 3, 6, 9, 18. There's our list. Okay. Not that we'll use all of those. We actually, we know that when we graph this, we're going to get something crossing the x-axis, hopefully, and getting an answer there. Okay, so somebody do that for us.
Why do you do all those fractions?
Do what now?
Why do you make all those fractions?
Because if it doesn't cross at a nice place, you got to know what to even try. Because can you eyeball the difference between 5/7 and 2/3? That's pretty hard to eyeball and get. So if it's in between 0 and 1, I know it's got to either be 1/3 or 2/3. That's the only fractions it could be.
Yeah.
And if it's not those, then I know something else is happening there. Okay, so that's the reason we want to make those, because we don't want to just be guessing. But at least we have, if we're going to guess, we at least have a smaller list to guess from than all the numbers in the world. That's kind of the idea there. But we're hoping we don't have to use fraction. But I think we do. So let's try not to start with fraction. So 3, 5, 25, 45, -18. Somebody that's graphed that equation already. -2 is a good one. Let's start with that one. Okay, so we would graph that equation, see where it's crossing the x-axis. We know -2 is in our list, and it crossed there. So you test that, you hit trace and type in -2, and it does. It crosses there. So we should get a remainder of what when we run -2 through 0. So bring down the 3 and then go to work. And yeah, I do get a 0 there. Okay. So I reduced the degree from 4 down to cubed, right? Which we don't know a whole lot about solving cubes. We want to get it down to what? Squared, quadratic. It's what we want to get it down to. If we can get it down to that, then we got quadratic formula, and that's going to spit us out the 2 other answers that they go with that. Or we could do factoring from there.
We have it at a third right now.
Yeah, we have it at a third right now. Each time that you do synthetic, it reduces it by 1. So we started with 4th power, now we're down to 3rd power. There's actually some options for 3rd power. If you remember your rules for factoring, that you could actually group that and factor it, and it does work. But let's kind of stay the course with synthetic division, because I think it works really well. So what's another place that original polynomial crossed the x-axis? Positive 1/3. And we would know that to try positive 1/3 because it's between 0 and 1, and we can see it's probably a little closer to 0 than it is to 1. So that's why we try 1/3 when we look at that graph. And running a fraction through synthetic is not the funnest thing in the world because it's fraction, but it's not boring. So, but it works the same way. So 3. It works out great for this one because you end up with nice numbers. 3 times a third is 1. That's 0. And then that's 0. That's 27. And then a third of 27 is 9. And there's a remainder of 0. Now we got this down from 4th degree up here. It was 3rd degree here in the blue. Now in the red, that's x squared. So we've got this down to this equation. 3x squared plus 27 is equal to 0.
Was there an easier way to find the number That would work like how much is the -2?
The graph. The graph is how you find that number. That's you're going to graph it. Where's it? Well, see where it's crossing the x-axis, and then hit trace and type in the number you think it is. The y should be 0 if it is, and that's how you're going to do that. All right. Now, how do we solve that guy? Several different ways we can do that.
Simplify that first.
Okay, how do we do that?
3 will go over 3 squared to 3
So I agree with simplifying it. So that I'm going to divide everybody by 3 just to get rid of it because I'm not got an x. GCF 3 is the only GCF. So I'm just going to turn it into x squared plus 9. Bless you. And then how can we solve that? It's a couple of different ways. Yeah, that's the easiest way. X squared equals -9. Then take the square root. You could have at the beginning if you wanted to. Eventually, you're going to have to divide by 3 anyway. We just did it at the beginning just to make it. It doesn't matter when you do that. That's true. You could have done that at the beginning. So what's the square root of -9? Plus minus 3i. So our zeros are x equals -2, positive 1/3, and then plus or minus 3i. How many answers did we get? 4. What was the degree of the original problem? 4. So they match. Okay, that should always be the case. Out of that.
And this was the last lesson we learned.
Except for we didn't find these, the complex ones. We stopped with the last lesson was on real solutions. The -2 and the 1/3 were the only 2 real ones for that particular polynomial. We're just adding in the complex today. That's the only thing that's adding to this.
So I can just like combine the homework today.
If that's what you want to do, sure. All right, let's look at another one. F of x. X to the 4th power plus 6x to the 3rd plus 2x squared minus 26x plus 17. Really nice to you on the P over Q on this one. Because P over Q is just 2 numbers, or 4 numbers technically. Plus or minus 1, plus or minus 17. 17's prime. And the leading coefficient there's 1, so it doesn't create any fractions on this one. So graph that. And I'm going to graph it as well on this one because it does something a little different. Hopefully that we recognize from section 1. Oops, I didn't get my plus sign. X raised to the 4th plus 6x to the 3rd plus 2x squared. All right, so I'm typing in that equation and graphing it. We should see something happening pretty special here. What's it doing? Touching the x-axis, bouncing off of it at what?
2. 1.
Yeah, 1. Couldn't be 2 because it's not a possible rational 0. So it's got to be 1 there. So what's that mean about 1?
It's multiplicity of 2.
Yeah, multiplicity of either 2 or 4. It's an even multiplicity. So we're gonna run 1 through that synthetic division for sure. So to verify that, I'm gonna hit trace and then type in 1 just to make sure that it's not just barely past 1 or something like that. I'm just verifying. Y 0. So that means 1 works in synthetic. Should work an even number of times. So I'm going to run it through the first time. 1, 6, 2, negative 26, 17. 1, 7. Well, here's the thing. Once you reduce it down the first time, it's going to go from 4th power to the 3rd power, right? And if we run it through a second time, it'll reduce it from 3rd power down to 2nd, and then we don't have to run it through again. we could use the quadratic formula to find the other two. And the other two may be ones, but I don't think they are. But all right, so where was that? 9 and 20, negative 26, negative 17. That's negative 17. That's 0. Remainder. That's wonderful. Nope. It's called synthetic division. Synthetic division. All right, so and then I'm going to run the 1 through again because I know it works an even number of times. And there we go. Hey, good deal. So I'm going to go ahead and write my zeros x equals 1 with a multiplicity of 2 on that. And then I've got a quadratic left over. Pretty easy to see that the answers to that are not 1. So looks like we ran out of ones to use. So what?
Teachers, please post your attendance.
I've already done that. Yay. So we got a quadratic. X squared plus 8x plus 17. What are my options? Factoring, is there anything that multiplies to be 17 has to be 8? No, so factoring's out. That's my next option. Quadratic formula. Completing the square is another option, but nobody ever does that one. But quadratic formula is where I go here. X equals negative b plus or minus radical b squared minus 4ac divided by 2a. Okay, so work this out. Negative 8 plus or minus, and then underneath that square root, that's going to tell us if we've got complex solutions or not. We should recognize from the graph that the other two answers are complex because does this thing, how many times does this touch the x-axis? Just that one time at 1. If it were other real solutions, then it would cross the x-axis again somewhere. But it doesn't. So we should know, okay, once I ran the 1 through and got this quadratic left, I should have complex solutions here because it doesn't cross the x-axis again. Complex solutions don't touch the x-axis. That's something you need to know. Okay, so I'm working this out at 64 minus 68, which would be negative 4, right? Over 2. And then we simplify that. Negative 8 plus or minus. What's the square root of negative 4? 2i, that's beautiful. And then we should simplify that to be negative 4 plus or minus I. Negative 4 plus or minus I. So we have 4 zeros, 1 that counts twice, so 1 and 1, and then negative 4 plus I, negative 4 minus I. 4 solutions. The degree was what? 4. Matches. 4th degree, 4 solutions. 4 zeros. Actually, only 1 x-intercept, but process to find them is the same though. Okay? Not too bad. Really, it's the same thing we did last couple of days. It's just we're saying the complex solutions are there now. So you got to remember to put them there. All right, let's do this one. I kind of threw this one extra in here. Let's say we had f of x equals x to the 4th plus x squared minus 42. Threw this one in here because this does come up. And I usually don't do an example like this, but I thought, it benefits you guys if I did. P over Q. We're going to go through the same process and see if something falls apart or works for us. You wouldn't say it falls apart if it didn't. So P over Q. Factors of 42. 1, 2, 3, 6, 7, 14, 21, and 42. Okay. So a lot of options for 42. Graph it and let's see what happens. x raised to the fourth plus x squared minus 42.
You don't plug in the x cubed,
There wasn't an x cubed.
don't you have to?
Well, you do when you go to do your synthetic. You don't when you go to graph it. If you put a 0x cubed in there, it's not going to change anything. So you could if you want to. You don't have to. So it crosses the x-axis, right? But remember our P over Q list. Did it have any fractions in it? Are those on nice numbers? What in the world? Well, if I zoom out, it ain't gonna get any better. Good idea, though. That's a good idea. So if you zoom out, it might look like they cross it into its spot, but they don't. So they're crossing somewhere between -2 and -3, and then between 2 and 3. Looks like the same place. So that's kind of interesting that that's happening. So I know it's got x-intercepts, 2 of them. But it should have 4, right? These are these repeated, like a multiplicity of 2 on either of these? No, so these are just 1 apiece. So it's got 2 real ones, and then probably 2 complex ones. How do we find those if our P over Q list doesn't help us? Well, that means these are not rational. Our P over Q list, remember, was the possible rational zeros. These are irrational zeros. So here's how you would want to go about trying to do that. So these are some, a little higher level skill here. That's a what? What would we call that as to classify that polynomial? We would call it a what? How many terms does it have? It's got 3 terms, so it would be called a trinomial. In Algebra 1, when you're factoring trinomials, what method do you use? The x. You still do that with this, even though it's not a quadratic. Okay? We want to multiply to be -42 and add to be +1. What does that? 7 and -6. Add to be positive, 7's got to be positive. Okay? So the factors then would be x squared minus 6 and x squared plus 7. Fancy. Okay. I can go straight to those factors because there's nothing in front of the leading. The leading coefficient is 1. Lets me do that. Now, what can I do with each of those? Solve them. Set them equal to 0. So x squared minus 6 equals 0. X squared plus 7 equals 0. So, that's not so bad. X squared equals 6. And how do you get that? Take the square root. So x equals plus or minus the square root of 6. Solve this one. X squared equals -7. Again, take the square root. What's that one equal to? Well, all of those are close.
Why did you keep it as just a practice it?
Because it doesn't simplify.
You don't want it to?
Well, I do, but it doesn't.
Is it plus or minus R?
That's the right one. 7 doesn't break down. The I is the negative coming out. Okay? And then radical 7 doesn't break down at all. Like we would normally do a factor tree and try to pull out the pieces that would, but it doesn't. Now, here's what I want to verify. I think the real solutions are which ones? The plus or minus radical 6. Is that where it's crossing the x-axis on our graph? Let's go back to that graph and look at it. If I hit trace and then I'm going to put in second square root of 6, that's the positive side. Hey, what do you know? 0. That's the correct intercept. And then this other one here would be the negative square root of 6. Thomas? Yeah, but it also had some others that you could do with synthetic to get there, yeah. This one didn't have any rationals at all. The one on the quiz yesterday had a rational, and then you could use the quadratic to get the radical 6 stuff out of it. Okay, so factoring is still a possibility that you might have to use that. So don't forget that it exists. All right. All right. So there's some solving. Let's build some polynomials. They call it forming a polynomial. All right. So example D would be form a polynomial with the degree of 3 with zeros, -5, and the square root of 6. Huh. If it's got a degree of 3, how many zeros should it have? What's the one that they didn't tell us about? Say it again. Yeah. The radical 6, we got the positive side of it. There also should be a negative side of that. Because if it's got a square root as a solution, then it should have had a plus or minus in front of it at some point. They're going to do that. They're going to say, okay, well, radical 6 is a solution. You've got to know, negative radical 6 is also a solution. Okay, because those come in pairs. Anything that's irrational comes in pairs. Anything that's complex comes in pairs. Complex conjugate theorem is what tells us that there's irrationals and and complex come in conjugate pairs. Conjugate pairs just means the plus and the minus. That's where that's coming from. So we've got to insert negative radical 6. They didn't tell us about this one. They didn't tell us about this one. Okay, but we got to know it's there because we're smart. All right, so we want to form that polynomial. So to form that polynomial, you're going to start with the factors for those zeros. What's the factor for -5? X plus 5. The factor for the square root of 6. And then there's the factored form. Let's build the standard form. Okay, so when you do this, you want to multiply the stuff with radicals or complex parts together first. Put those together because then the radicals will go away and the complex parts will go away. So I'm going to do these two first. So FOIL method, distributive property, whichever way you do that, doesn't matter. X times x is still x squared plus x radical 6 minus x radical 6 minus the square root of 36. That's what that's going to turn into. You still got the x plus 5 out here in front. Okay, so just some basic algebra 1 there, just multiplying x times both of those terms. That gets this part. Negative radical 6 times both of the terms. That gets that part. Then you want to simplify that. Well, what happens to the radical 6 stuff in the middle? They cancel each other out. That's great. What's the square root of 36? 6. So that ends up being x squared minus 6 times x plus 5, which is really not that bad. Because then you just distribute the x, that's x cubed, and x and minus 6x, and then plus 5x squared minus 30. And then rearrange it so that it's in descending order because, mathematicians are OCD like that. We got to have things in order. And you found the polynomial. Or excuse me, you formed the polynomial. That sounds like you did something really amazing. You formed it. Very much unlike the way God formed people out of Yes. In my book, it is wrong. Descending order. That's not that hard to do. Not asking you much. All right, let's look at another one. Example E. Last one of the day. We'll do degree 3 with zeros 5 and 3 minus 2i. What's the one they didn't tell us about? 3 plus 2i.
Always have.
Yeah, always have a positive and a negative. That's right. They didn't tell us. Well, they didn't say. That should be a category on Jeopardy. I think they didn't say for 500. And it'd be all complex and, irrational conjugates. They'll never have that on Jeopardy. They'll put math on there. People can't do it. All right. So, what are the factors that build this? X minus 5. That's the easy one. Now what?
X plus 3 minus 2i.
It's minus. It's always minus. Unless that's a negative in the front. It's always a minus because this is coming from x equals 3 minus 2i. And to get that stuff over on the other side, you got to subtract it. That's where that minus is coming from. Okay. All right.
So if I had like a middle equation or something like that, it's minus.
Yes. It'll turn into a plus if the real part of the complex is a negative. Like if this was negative 4, it'd be x plus 4 plus 2i, and x plus 4 minus 2i. It's always the opposite of what's there. So if it's a positive, it's a minus. If it's a negative, it's a plus. That's how that
So
works.
why are they both?
Because the real part's positive, so that's why it's subtracted. And then the plus or minus takes care of the is on the complex part, not on the real part. All right, now the hard part is multiplying the complex things together. But it's just distributive property. If you'll think about it that way, it's not that bad. So I'm going to distribute x. X squared minus 3x plus 2ix. And then I'm going to distribute the negative 3. Minus 3x plus 9 minus 6i. And then I'm going to distribute the negative 2i. So that's minus 2ix plus 6i minus 4i squared. So it's long, but a lot of stuff cancels out. Right? I just did distributive property. That's all I did. X times x is x squared. X times negative 3 is negative 3x. X times 2i, 2ix. Negative 3, negative 3x, positive 9, negative 6i.
It's kind of like you're squaring your multiplying 2 trinomials.
Yes, that's exactly what it is. Those are trinomials. That's exactly what I'm doing. Multiplying 2 trinomials. That's a great way to think of it. All right, so the great thing about this is all the I stuff's going to cancel out. Okay? Because we got 2ix, and here's a negative 2ix. And then we got, those are x's. They're not going to cancel. There's a 6i, negative and positive. What do? They cancel each other out. All right? And then, what does negative 4i squared turn into? 4 times negative 1, which is positive 4, right? Now, let's put the stuff together that matters. X squared minus, those two are together, so that's negative 6x. Then we got a positive 9 and a positive 4, which is 13. Oh, well, that turns out actually really nice. And doesn't look that bad. Not nearly as intimidating now as it was. I squared is negative 1. And then, so change I squared to negative 1, so negative 4 times negative 1 is what that is. You may not remember that from Algebra 2. I is the square root of -1. I squared is -1. I cubed is -I. And I to the fourth is +1. That's the conversion thing that you learned in Algebra 2. That you may or may not remember. If you don't, it's not that hard. Then distribute the x minus 5 to everything. So that's x cubed minus 6x squared plus 13x. And then distribute the -5. So -5x squared positive 30x, bless you. And then -65. And then combine the like terms. X cubed minus 11x squared 43x minus 65. Okay, so I just distributed x to get the top line, and then I distributed -5 to this to get the second line. And I just stacked it up that way so the like terms are together. Don't have to do that. It just makes it easier. To me, it makes it easier. That's the way I've done it since I was a wee lad of 16.
We die.
All right, so all right, so we got this polynomial out of that. You should be able to verify that by graphing that and seeing where it crosses the x-axis, right? You can graph that and say it should cross at what? At 5, right? And then if it doesn't cross at 5, you probably screwed it up somewhere in multiplying. That's where it's going to happen. Okay.
Is there not any long division?
No long division in this. All right, so there's the problems you need to look at for this particular section. You can work on them a little bit today, get started, and then Tuesday you can work on them when you come in, because I'm sure you'll look at them Monday where you're off, right? And then, yeah, I know you would.